with Algebra 1, lines and parabolas had equations, right? Lines and parabolas had equations. Now, you might say, well, okay, for what we've done, triangles, quadrilaterals, do they have equations? Well, they're made of lines. So not really. I mean, they have like a triangle, 3 different lines that make up a triangle. But no, there's not a new equation for them. Circles do have an equation, though. Now, you notice kind of on the middle of page 12 there, I put a little chart there. These are based on conic sections. So if you haven't heard of that before, parabola was one of the conic sections. There are 4 shapes that you have equations to. The first one that you did was a parabola. It's this second one, actually. We can get the equation of a circle as well. There's an ellipse and there's a hyperbola. So these are 4 shapes you get from a cone. All right, a double cone that you can form by passing a plane through them. And we can get an equation of each one. So we're doing an equation of a circle. Yeah, so let's go. I think it's just the next page. Right. Now, they want us to know how to show the equation of a circle. So they say, using the Pythagorean theorem or the distance formula, they're equivalent. I actually kind of want you to know that. These are equal. They might look pretty different. They're actually equivalent equations. So they just look different. So using either Pythagorean theorem or distance formula show how to derive the equation of a circle with a given center and radius. So that's what we're going to do. Here's the circle as a radius of r. The center is the point hk. And xy is any point on the circle. Right, so I chose that point, xy, any point on the circle. Let's show how we get the equation of a circle. Now really, it's just using one of these 2. Because you remember that a circle is all points that are the same distance away? So really, what we're doing is we're finding any of these, because they're all the same distance away. Any point on there is the same distance away from that center. Okay, so what I'm going to do, and I'm going to do Pythagorean theorem, and I'll show you how distance formula is the same. So for Pythagorean theorem, you naturally do this, right? You have to make a right triangle. Then you have to just plug them in Pythagorean theorem. So I'm making a right triangle like this. Now, if I actually knew the points, let's say that this was like 2, 4, and this point was like 5, 8. Okay. What I'd be able to do is count from here to here, and I get 3. Now what I actually did was take 5 and subtract 2. That's how we would have gotten 3. We really did 5 minus 2. So we did this value minus that value. That's the length of this segment. So that's what I'm going to do here. This length, in terms of the variables, is this value minus that one.
Oh, that's like the distance formula.
Well, I'm doing Pythagorean theorem, but it will be, yeah. So write down Pythagorean theorem, and our a value is going to be the bottom here. And I just said it's this x minus h. That value, 5 minus 2, x minus h. That's a. By the way, you could write these separately first if you wanted. I'm just plugging them in already. So then, same idea for the vertical here, like the b value. It's 4 to 8, so it'd be 4. Really what we did, though, is we took this one, 8 minus 4. That's what you would really do, is subtract those to find that length. 8 minus 4. So we do the same thing here. This value minus this one is going to be this length. Y minus, I wrote it wrong, y minus k. And finally, the hypotenuse is the radius. So c is r, so it's r squared. Oh, I went too far. That is the equation of a circle. This the base standard form of the equation of a circle. So it has, just like a parabola, remember that was like x minus h squared plus k, use H and K with this?
Oh, yeah.
Maybe. That was a parabola, so that's something to this effect. So notice this has an H and a K being our center. I'll talk about that in a minute. X and Y is any point on the circle, and R is, of course, the radius. Now, I want to show you the distance formula is equivalent. So this is on that formula sheet over there. That's the distance formula. It's actually identical because if I just did a square root of this, D is distance, not diameter, by the way. If I just did a square root and I plugged in those coordinates, it would be the exact same. X minus something squared. You see how it's like it's the exact same form. Okay, so I could have done this form. I chose the Pythagorean theorem, they're equivalent. Either one would work. So I want you to know basically this, just how, well, this minus this, x minus h is a, y minus k is b, and you plug it in the formula for Pythagorean theorem. So let's do a couple equations. I'll show you how we actually apply this, but this is the base form. Well, if I get rid of that square root. Any initial thoughts, questions I can answer?
What are you trying to get rid of?
I'm trying to get rid of that square root. There we go. Okay, so let's see this in action. First example, what is the standard equation of a circle with this center and diameter 18? By the way, I should mention up here, remember R was the radius, and then HK, that's the center of your circle. So those are really the two things you need for a circle. You need a center and a radius. All right, somebody write it down for this one. The standard form, just writing the equation from above. Now, just like parabolas, or even lines, like the equation of a line, your final equation will have x and y in them. Okay, so parabola, same idea. It's like 3x squared plus 4 or something. They have x and y in them. So the x and y are going to remain, but we're going to plug in hk and r. So the center is hk. So -3 is my h, and k is my 11 is k. So I'm going to plug those in. So I'm going to keep x and y. It's going to be x minus, now h, be careful, it is -3. So really, it's this, x minus a -3. So it becomes +3. Don't forget the squared. Sometimes one of the most missed things is just students don't write squared. Plus y minus k is 11. So notice on those, it always looks like the opposite number here. It was at -3, but over there it looks like +3. Here it's 11, it looks like -11 there. It always looks like that number. All right, and finally, r squared. So the diameter is 18. So the radius is 9, half that. And yes, it's 9 squared, but you do work that out as 81. So for a center with -3, 11 and diameter of 18, that's the equation of the circle. Hmm? By the way,
And then just any point on the circle?
yes, x and y is any point on the circle. So any point on here that when you work it out, it gets 81. That's a point on the circle. By the way, I'm going to ask tomorrow, if you have a phone, that's all right. But if you have some type of device, I want to show you how we're going to plug these into Desmos. Because Desmos will plot these circles. Okay, they'll actually graph them. All right. Now, let's do example 2, and then I'll see if there's questions. Because 2 is just going backwards. So this one was, here's information, what's the equation? This is, here's the equation, state the information. All right, so, and we'll graph it. So here's an equation of a circle. The center of the circle, and why don't you write it down? Take a second. Write down the center and what you think the radius is. This is actually almost pure algebra here with all these. It's not a lot of geometry. Okay, let us continue. What is the center? Nice. Using the fact again that this is the x value. That's the x value of the center. This is the y, but they look like the opposite values. So it's 2, -4. Okay, somebody else. What's the radius? Want to raise their hand? So this is, yeah, and again, here's some of my students were at 36, but that's r squared. Yeah, sweet. So you have to do a square root of that to get the radius. Yeah, technically, you could, this is where you would technically use your compass. Now, I'm okay if you just want to sketch it for this, but you just do a radius of 6, so that'd be here, and then you would draw on your circle with the compass. Now, if you don't have a compass out, you could just do up, down, left, right, 6, and then make a sketch. That was bad. Okay, so after we did those, so it showed it each direction. Any questions I can answer on that? All right, let's keep going. So each of now you can do it. So guys, each of these moving forward, they kind of give you different information and ask for something, or they give you less information. So this one, example 3, find the equation of the circle. Here's our center. We got an HK that passes through the point -1, 1. So this is, this is an XY point. It's a point on the circle. The circle goes through that point. So let me start to write the equation with 4 and 3. So it's always x minus h squared, so it's x minus 4 squared, plus, parentheses, y minus k squared, k is 3, equals r squared. So notice here I don't have the radius yet. Yeah. Easiest way to do this one is just to plug in, because that's a point on the circle. So you can plug in -1 for x and 1 for y and solve for the radius. Now, I will say there's another way you could do this. What else do I do sometimes? I don't remember. Maybe I'll think of it here. So anyways, you can just work this out. Please note that all of these values are going to be squared, so you have to turn them positive. Sometimes I see here -25, but it's not. It's -5 squared, which is positive. -1 minus 3 is -2. And that squared is positive 4. Okay, and you get 29. Now, note that in the formula, we don't need r, so you don't have to do a square root. We just want r squared. Yeah, so if you're graphing it, you would do a square root. But for the final equation of the formula, I just got to plug in 29, because that's r squared. So I got x minus 4 squared, I got the plus y minus 3 squared equals 29. So I use the x and the y, but then I write my final equation, x and y back in there, not the -1 to 1. Epic, wow.
Did you just say epic?
I thought you did.
I did say epic.
That
But you
is-
said it too.
oh,
So that's
that makes me happy.
why is this epic? He said epic.
Why? How is it not epic? I mean, everything about it said awesome. So they give it a little less information. So let's keep going. I think just because of time, I'm gonna skip this one, and I'm gonna go on to number 5. Ah, this is a great one. They're giving us less information here. They don't even give us a center this time. So flip the page. I'm on 5. Write the equation of the circle. There's the diameter. I'm gonna write just write down the standard form first. So they do not give us the center, they don't give us the radius, they give us the endpoints of the diameter. I'm going to make a quick sketch. -15.6, somewhere like there. -7, -2, it's like there. So we need the radius and we need the center, okay? Because because that's what will get us a circle. Now again, this is a diameter. So here's my first question. If that's a diameter, and we want the center, how can I find the center since that's a diameter?
Be careful. Don't even say.
Midpoint.
Oh.
Now remember, midpoint, there's many different ways. It's an average. You can also count. Remember how you could just like count down and over? If you're, we'd have to graph it. You count down and over, and then do half of that. Okay, so you can do that. Or the midpoint formula, not on the formula sheet, it's an average. It's summing the x's dividing by 2. And then summing the y's and dividing by 2. It is down 8 over 8, isn't it? Is that what it is? Yeah, you're right, it is down. So if you're counting, then you could go down 4, right 4, and we'd be at our point. So actually, I like that better. So if we went down 4, we'd be at 2. And if we went right 4, we'd be at -11. I'll show it to you up here. It'd be x is -15 plus a -7 divided by 2. And then the y's would be 6 plus a -2 over 2. Again, not minus, it's plus. That's why I almost like the counting method. Counting method better. So this would be -22 over 2, and this would be 4 over 2. And therefore I get what I said here, -11. That's the midpoint, so then I'm going to start to plug it in. Again, this is h and k. So it's x minus a -11 for h. So it becomes +11. Plus squared plus y minus k, which is 2 squared, equals r squared. Okay. Now actually, guys, we have a point on the circle. I actually have 2. It becomes the last problem. The last one, where you plug in x and y. So now it's actually identical to that. So I can plug in either one. I'll just plug in -7, and I'll plug in -2. I know, it's this one. An alternate way to do it is if you want the radius, you could do Pythagorean theorem between just 2 of these points to get the radius. So an alternate method, I could make a right triangle. Sometimes not the diameter, just the radius. I guess it's 4 and 4, right? Is that what it was? So you could, so then this would work as well for the radius. Okay. And but then you got to square it because you want r squared, not r. Back to this one. If you're just plugging in x and y, you simplify. That's 4. So 4 squared is 16. This one, -2 is -4 squared. That's also 16. And so you actually get what we would have gotten over there, 4 squared plus 4 squared. So we get 32 is r squared. And you don't have to do a square root because we actually just want r squared. Okay, so final equation. We need the x plus 11 squared plus the y minus 2 squared equals the 32. Okay. I think I'm going to finish with the bottom example, but I want to do example 6 tomorrow. But I think I'm going to finish with example 7. So this one was with diameter. Make sure to read carefully what parts they give you and what parts they leave out. So anything I can answer on 5? Okay, so let's come back to that one tomorrow. Let's do the example 7 at the bottom. Guys, here's a pretty simple thing about circles. It says how to know if a point, they might ask, here's a point. Does that point lie on the circle? Does it lie inside the circle? Does it lie outside the circle? Okay, you might be able to guess this one. If you plug in the values, so you have an equation, and you plug in x and y. Like, we could go back to like this equation that we were working with. Let's say you're trying to say, is negative 4 or 6? Is that point on the circle? Well, if you plug negative 4, 6 in, and you work all this out, and it equals 32, it's on the circle. Okay, so you can do that with any equation. Just plug in a point. If the number you plug in, you end up getting a number larger than r squared, so from the last one, something larger than 32, your point is outside the circle. And if you get a number less than the r squared, it's inside the circle. Yeah. So let's just do this one at the bottom to show you what I mean. You have x squared plus y squared equals 4. Does the following 2 points, they lie in, on, or outside the circle? Show algebraically, so work it out and see. Oh, also, here, this is a good example as well. What's the center of this circle? 0, 0. Because it's unwritten as a 0 there, but they simplify x minus 0 to x. It has a radius of 2, but yeah, note that if the circle doesn't, if it's just x squared, not x minus or plus something squared, that's a 0 for that coordinate. Okay, so in any case, if I plug in 1 here, and I plug in square root of 3 for y, 1 squared is 1, square root of 3 squared is 3. That's 4. So you should put on the circle. What about this one? If I plug in 2 and 1, it's 4 and 1 is 5. That's greater than 4. So this is outside the circle. You got a number less than 4 to the inside.